Hello everyone, this is Bylane. Welcome to this course. In this course, you'll learn hands-on how to create high-quality renderings for fashion 3D design using Marvelous Designer, Blender, and AI tools. Right now, you have the opportunity to acquire cutting-edge 3D skills demanded by the fashion industry. Whether you aim to become a freelancer, advance your career at your current company, or create a new side income stream, this course provides the essential skills to achieve your goals. I'm interested in fashion 3D, but I don't know where to start. I tried teaching myself Blender, but the information was fragmented, and I got stuck on how to proceed. I want to express fashion design digitally, but I worry that without a natural sense of style, I can't become a creator. Does this sound familiar? Actually, many people share these same concerns. But rest assured, this course is designed so even complete beginners can steadily build their skills step by step. For those interested in the apparel industry or 3D CG production, this course carefully teaches practical workflows from the very beginning. Specifically, you'll learn to create garments in Marvelous Designer, arrange designs, adjust silhouettes, and reproduce natural fabric textures. Then, using advanced texture settings and lighting in Blender, you'll give your work a professional finish. Furthermore, you'll learn how to significantly reduce production time while maximizing quality by leveraging the latest AI technology. We cover the entire process, from garment fitting and design adjustments to detailed texture settings and final high-quality rendering. By the end of this course, you'll be able to freely create your own original 3D garments. You'll complete work you can confidently include in your portfolio. You'll gain practical skills demanded by the apparel, gaming, and film industries. You'll acquire the technical proficiency and workflow necessary to secure freelance work. In other words, this course isn't just about learning how to operate software. It equips you with the practical skill set to elevate your career to the next level. This course is perfect for those interested in fashion design who want to express fashion using digital tools, beginners who want to learn 3D CG but don't know where to start, those aiming for career advancement in the apparel industry, those wanting to work on costume design for games or video production, and those looking to build a strong portfolio to land jobs. No prior specialized knowledge is required. Basic computer skills are all you need. By the end of this course, your work should reach a quality that surprises even you. See you in the next lecture. Let's create your creative future together. Hello, everyone. Now, let's introduce the 3 essential software programs we'll be using in this course. You might be thinking, using so many programs sounds difficult, but don't worry. Each software has a clear role, and by combining them, even beginners can achieve professional-level quality. So, let's take a look at each one. First up is Marvelous Designer. This software is a specialized tool for creating 3D garments. It's designed specifically for handling fabric, enabling you to recreate natural textures, wrinkles, gravity-induced draping, and realistic movement that look just like real cloth. In this course, we'll carefully learn how to use Marvelous Designer for creating basic costume patterns, dressing avatars, fabric simulation, design adjustments, and creating variations. Next up is Blender. Blender is free, open-source 3D CG software. It includes every feature used in professional production environments, modeling, texturing, lighting, and rendering. Blender's greatest appeal is undoubtedly its high level of freedom. Creators worldwide use it, and it boasts an incredibly robust community and tutorial resources. And best of all, it's free, so you can hone your skills to your heart's content without worrying about additional costs. In this course, using Blender, you'll learn key processes for finishing your work. Importing costumes created in Marvelous Designer, setting up high-quality textures and materials, building professional lighting, and achieving beautiful final renders. These are the crucial processes for completing your work. Hello everyone. In this lecture, we'll learn about Marvelous Designer's screen layout and basic operations. First, let's start by explaining how to view the screen. The Marvelous Designer interface is mainly divided into two areas, the 3D window and the 2D window. In the 3D window on the left, you can dress avatars and view three-dimensional simulations. In the 2D window on the right, you can create and edit patterns. Working back and forth between these two windows is the fundamental workflow in Marvelous Designer. The animation editor is hidden at the bottom of the screen. Here, you can also create animations. Various icons for operations and display settings are arranged at the top of the screen. You can access various functions from here, so take your time getting familiar with them. For example, to toggle the avatar display on/off, you can change it using this icon. This is useful when you only want to see the clothing. For displaying 3D garments, select from the Garment Rendering Style options. The most commonly used are Thick Textured Surface and Textured Surface. Choosing Thick Textured Surface visually represents the fabric's thickness, resulting in a more realistic appearance. You can also change the avatar display style, switching to Monochrome Surface or Show Wireframe to choose a view that's easier to see based on your task. Similarly, you can change the two D-screen display options from the top toolbar. Here too, you can primarily use Garment Rendering Style to change how the pattern appears. The Object Browser in the upper right organizes the elements you've created. Elements used in your project, such as fabric, graphic, button, buttonhole, top stitch, and puckering, are displayed here. The property editor in the lower right allows you to configure the detailed settings for the selected element. Physical properties and fine adjustments for each part are handled here. Next, let's learn mouse operations. Left-click to select. Hold the wheel button and drag to move the view up, down, left, or right. Rotate the wheel to zoom in or out. Hold the right-click and drag to rotate the viewpoint. These operations take some getting used to at first, but they will become second nature with practice. Take your time and practice without rushing. When you select a pattern, a tool called the gizmo appears in the 3D view. The gizmo is a handy tool that lets you intuitively move, rotate, and scale objects. You can choose the gizmo type in settings, but World Coordinate is recommended for beginners as it's easier to handle. In the 3D view, you can quickly switch perspectives using the number keys. 2. Front view. 1 and 3. Diagonal views. 4 and 6. Side views. 5. Top view. 8. Back view. Remembering these view switches makes checking your work easier. Finally, save your work. Select Save As from the File menu bar and save in project format. We recommend getting into the habit of saving frequently. In this lecture, we learned about the screen layout and basic operations. In the next lecture, we'll go over how to load avatars and adjust their dimensions in detail. See you in the next lecture. Hello, everyone. In this lecture, we'll learn how to display avatars and adjust their dimensions. First, let's display an avatar on the screen. Click the library icon in the top right corner of the screen. Alternatively, you can press the shortcut key Y. Once the library opens, click Avatar. A list of avatars will appear. This time, select your preferred female avatar from the Female folder. Double-click the avatar or drag and drop it onto the 3D window to display it in the 3D scene. A convenient feature of Marvelous Designer is the ability to easily edit detailed measurements, like the avatar's height, bust, waist, and hips. Click the Avatar tab in the top menu, then click Avatar Editor. The numerical measurements for each part of the avatar will be displayed. Simply enter the desired values for height, bust, waist, hips, or any other part you wish to change, and the avatar's body shape will update in real time. Feel free to adjust it freely to match the target size for the clothing you want to create. To change your avatar's appearance, try adding accessories like hairstyles or shoes. Inside the Female folder in the library, you'll find an accessory folder. This contains various hairstyle and shoe models. Using them is simple. Just double-click or drag and drop your desired item onto the avatar to apply it. Experiment with different options to find a style that fits your vision. Next, let's change your avatar's pose. The Pose folder inside Female contains multiple poses. Apply these the same way. Double-click or drag and drop. Sometimes after using a preset pose, you might want to adjust it further. In that case, turn on Show Avatar Joints. This displays the avatar's bone structure. Select the joint you want to adjust and use the gizmo to move it, allowing for precise pose tweaks. This is useful for minor posture adjustments or pose refinements, such as slightly changing the arm angle or adjusting the direction of the neck. By the way, you can quickly toggle the avatar joint display on-off using the shortcut key Shift+X. It's handy to remember. The library offers various types beyond female avatars. Male avatar, baby avatar, kids avatar, mannequin avatar, metahuman avatar for Unreal Engine. Select the appropriate avatar based on the item you wish to create. Note that the library also includes a fabric section, which will be covered in detail in future lectures. Now, let me introduce a very useful feature. Connect within the library. Connect allows you to download clothing and objects for free or for a fee. Connect has the following categories: garment, fabric, trim, avatar, scene. Free items are especially recommended for beginners. Check Free in the filter at the top of the screen to display only free items. When you find an item you're interested in, right-click on it and select Add to Cart. Once the item is in your cart, click the Order button. There's no charge for free items. After downloading completes, double-click the item's image to add it to your project. Before using any item downloaded from Connect, always check the license information. It details usage terms, including whether commercial use is permitted and whether credit attribution is required. We strongly recommend reading it thoroughly to avoid any potential issues down the road. Hello, everyone. This time, let's learn the basic operations of Marvelous Designer by creating a simple t-shirt. This time, we'll use the t-shirt template provided by default in Marvelous Designer. Open Garment from the library in the top right corner. Find T-shirt inside and double-click to load it. This will display a t-shirt with its placement and seams already set up. Although this t-shirt is already complete, we'll intentionally reset its placement and seams so we can learn the operations step by step. First, delete the seams. Select Edit Sewing from the top toolbar, press Ctrl+A to select all seams, then press Delete to remove them. Next, switch the tool to Transform Pattern. To practice placing the pattern on the avatar, select all patterns with Ctrl+A. Then, right-click in the 3D view and select Reset to Dearrangement selected. Here's an important point. Remember how to distinguish between the front side and back side of a t-shirt. In Textured Surface view, gray indicates the wrong side, back, while white indicates the right side, front. In Thick Textured Surface view, both sides appear the same. Typically, you start modeling in Textured Surface view and switch to Thick Textured Surface when refining the details. The pattern overlaps with the avatar and is difficult to see, so use the gizmo to move it to the side. Since this t-shirt has the front and back bodice panels separated at the center, we'll merge them first. Switch to the Edit Pattern tool, right-click the center line, and select Merge to combine the patterns. Next, we'll place the pattern on the avatar. To display arrangement points, press the shortcut key Shift+F. Blue arrangement points will appear on the avatar. Select the pattern in the 2D view and move it close to the blue arrangement point in the 3D view. Marvelous Designer will automatically determine front and back and place the pattern correctly oriented. Be careful to place the left and right sleeves correctly. Once you've finished sewing, it's easier to work without the placement points showing, so hide them. Once placement is complete, it's time to sew the pieces together. Marvelous Designer offers 4 types of seam methods. We primarily use 3 types frequently, so let's look at each one. 1. Segment sewing. This function sews a line from point to point and is often used where there are few points along the pattern line. Click the part you want to sew, then click the destination point again to complete the seam. Ensure the direction of the sewing notches is the same on both sides. If the directions are opposite, the fabric will twist when sewn together. 2. Free sewing. Allows you to sew together any distance freely. Click the starting point, drag to your desired position, and click. Then click the starting point on the destination piece, and finally click once more to complete the sewing. 3. MN free sewing. Use this when sewing together 2 or more patterns. For example, let's look at sewing the bodice to the sleeve. First, sew the bodice from the front panel to the back panel, then press the Enter key. Then sew the sleeve, and finally press the Enter key to complete the MN free sewing. Be careful not to forget to press the Enter key, as the sewing will not complete otherwise. Now let's sew the remaining sections. Once sewing is complete, let's see how the garment actually forms. Press the simulation button or the space bar to start sewing in the 3D view. Press the space bar again to stop the simulation. Long press the simulation tool to expand the menu. There are 3 simulation modes: Normal, Default; Animation, Stable; Fitting, Accurate Fabric. You can also choose between CPU and GPU. If your PC has a GPU installed, you should be able to select GPU. We generally recommend using Normal, Default, and selecting GPU if available for smoother performance. Since this t-shirt lacks a collar, we'll create it in the 2D view. Click the rectangle tool or press the shortcut key S, then click in the 2D view. A dialog box will appear where you can enter the width and height. The collar dimensions should be about 90% of the neckline dimensions. Since the neckline distance measured is 473.5 millimeters, set the width to 426 millimeters, 90% of that, and the height to 20 millimeters. Next, sew the bodice and collar together using MN free sewing. Use segment sewing to stitch the collar edges. To position the collar correctly, switch to the Transform Pattern tool and select the collar. Right-click on the 3D view and select Superimpose Side to neatly position the collar at the neckline. Run the simulation to verify the seam alignment. Set Bond to stiffen the collar and give it structure. Switch to Transform Pattern, select the collar, and find Bond Skive in the Property Editor. Expand it and check Bond to add stiffness to the collar. Bond has various presets with different stiffness levels. Choose one closest to the look you want to achieve. Setting Bond changes the color in the 3D viewport. If you don't want this color change, uncheck Show Bond/Skive in the toolbar under Trim Display. The top edge of the collar has wrinkles, so we'll fix it using elastic. Switch to the Edit Pattern tool and select the top edge of the collar. In the Property Editor, turn on Elastic, set the ratio to around 96, and run the simulation. It should now follow the shape of the neck. Here's an important point about simulation. As you refine the details, you'll need to toggle the simulation on and off frequently. Get used to switching it with the space bar. It will significantly improve your workflow efficiency. With simulation active, you can pull and manipulate the pattern to shape it. Refine it until you achieve the desired form. This completes the basic pattern placement and sewing process. Next, we'll adjust the mesh density, a crucial setting. You can change the mesh density by selecting the pattern and modifying the particle distance value in the property editor. Lowering the particle distance value allows for more realistic wrinkles and drapes, but this also increases the load on your PC and slows down performance. For workflow, start modeling with a particle distance of 20. Gradually lower it as you work on refining the details. As a final guideline, larger parts like the bodice are often set to 10 to 15, while smaller parts or those with elastic specifications are often lowered to 5. You can choose between triangle, quad optimized, and quad grid for the mesh shape. I often model using quad optimized. The reason is that I feel it allows for a softer representation of the fabric. Try them out and choose the mesh shape that works best for you. Hello everyone. This time, we'll learn about texture fundamentals and various maps, an important element for giving clothing realistic texture. Having this knowledge will significantly boost the quality of your work. First, let's start by simply adding color to the t-shirt. Select Fabric 1 from the object browser. In the property editor at the bottom right, you'll find the base color field. You can change it to any color you like by clicking the color option. To change the color, you have two options. If you have a specific color in mind, you can enter the RGB values or color code. Alternatively, if you want to pick a color from the screen, you can use the eyedropper tool to sample it. After selecting a color with the eyedropper tool, press the Escape key to apply the change. Once you've decided on a color, click the Add button. This makes it easy to reuse that color the next time you open the project. Click Apply and Close. You can create multiple fabrics using Add or Copy. For example, use this when you want different materials for the bodice and collar of a t-shirt. Drag and drop a created fabric onto a pattern in the 2D view to apply it to that pattern. Select a fabric and configure detailed settings via the Property Editor. Now we're getting into the real texture configuration. Now let's explain the various maps. 1. Base color map. The base color map defines the fundamental color and pattern of the fabric. This is the most basic and essential map. Click within the base color map to load an image file. You can load data you created yourself, purchase data, or freely distributed texture data. 2. Normal map. The normal map is used to express surface texture and depth. The key point is that it creates a sense of three-dimensionality without altering the actual geometry, enabling realistic texture representation. There are several ways to create a normal map. You can create it in Photoshop, use the free online tool called Normal Map Online, or generate it automatically in Marvelous Designer. 3. Displacement map. Unlike normal maps, which create the illusion of depth, displacement maps use grayscale images to physically move vertices and create actual 3D depth. They're primarily used for thick knit fabrics or materials with significant texture. However, keep in mind that since they actually deform the mesh, they increase both data volume and render times. We recommend using displacement maps only when absolutely necessary. 4. Opacity map. The opacity map controls a material's transparency. Its primary uses include representing the transparent and opaque areas of lace fabric, creating fringe effects, or working with mesh materials like sportswear. It uses a black and white image, where white areas remain opaque and black areas become transparent. 5. Roughness map. The roughness map controls surface roughness and determines light reflection characteristics. This setting significantly alters the fabric's texture. Use it to create smooth reflections like silk, coarse textures like linen, or a satin-like sheen. 6. Metalness map. The metalness map is used to represent metallic surfaces. Since most fabric are non-metallic, this map is rarely used. However, it can be applied to embroidery using gold or silver thread, or fabrics with a metallic finish. Next, let's set up the fabric's physical properties. This is crucial for creating realistic fabric movement. First, select a preset from the library that closely matches the fabric you want to create. You can also add fabrics from the library's fabric section to the object browser. The fabrics in the library already have various maps applied, making them useful references. Fabrics have detailed settings that you can adjust. The recommended workflow is to first choose a preset that closely matches your intended fabric, then run the simulation and observe the movement in the 3D view while adjusting each value. Run the simulation and observe the movement in the 3D view while adjusting each value. This workflow efficiently guides you toward achieving your ideal texture. Now, let's examine the main settings. 1. Stretch. Stretch controls how easily the fabric stretches. Lowering the value makes it behave more like an elastic material. 2. Bending. Bending represents the fabric's stiffness. A higher value creates thick, stiff fabrics like denim, while a lower value produces soft fabrics like chiffon. 3. Buckling ratio. Buckling ratio controls how easily the fabric bends. A higher value makes it bend easily and wrinkle readily, while a lower value makes it resist bending and wrinkling. This is an important setting when adjusting drape. 4. Buckling stiffness. Buckling stiffness controls how easily the fabric's corners bend. A low value makes it easier to fold, while a high value makes it harder to bend. This is an important setting when creating items like pleated skirts. 5. Internal damping. Internal damping controls the suppression of fabric movement. Increasing the value makes the simulation move slowly, as if in water. A low value results in light, airy movement, and easy fluttering in the wind, while a high value creates heavy, deliberate movement. 6. Weight. Weight represents the fabric's mass. Light fabrics include chiffon and organza, while heavy fabrics include wool and leather. This affects how drapes hang under gravity. 7. Friction. Friction is crucial when using animations. It prevents fabric from slipping during animation and adjusts the movement of overlapping fabrics. If clothing slides off the avatar during animation, increasing this value often resolves the issue. Save your customized presets to reuse them with other data. Create plenty of your own unique materials. Hello everyone! This time we'll learn how to place graphics. Let's learn how to add logos and print patterns to garments. To place a graphic, click the Graphic 2D pattern icon in the top toolbar of the 2D window. From this dialog, select the graphic image you wish to place. After selecting the image, click on the 2D pattern where you want to place it, then press OK to load the graphic. Simultaneously, the graphic will also be stored in the object browser. After loading the graphic, the tool automatically switches to the Graphic tool. In this mode, you can click the graphic on the 2D pattern and drag it to change its position, rotate it, or resize it by dragging the corner handles. The operation is intuitive, so feel free to adjust it until you achieve your desired placement. You can also set graphics to display as repeating patterns. With the graphic selected, open Tile in the Property Editor and set it to Pattern. The graphic will automatically be converted to a pattern and display repeatedly across the entire area. You can adjust the pattern repetition along both the X and Y axes, so feel free to experiment with different values. To create an effect where the print appears to connect across a seam, check the Over Seam Line option in the Property Editor. When you move the graphic to the seam position, it will naturally connect and display across the seam. Next, let's look at detailed settings to make graphics appear more realistic. Select the graphic you want to configure from the object browser. Within the Property Editor, you'll find a Material section where you can select the type. Types include fabric matte, fabric shiny, fabric velvet, etc. Choose the appropriate type based on your purpose. You can apply the various maps learned in the previous lecture to graphics as well. A useful feature is the Use Same Map as Fabric checkbox. When you check this option, it automatically applies the same map settings as the fabric the graphic is placed on. This helps the graphic blend naturally into the fabric for a more realistic appearance. Finally, here are some notes and tips. Use the highest resolution images possible for your graphics. Using PNG format images with transparent backgrounds allows you to place logos cleanly. Be careful with images that have a white background, as they may display a visible white border. When placing multiple graphics, name and manage them using the object browser. Hello everyone! In this lecture, we'll learn how to make a pleated skirt. Mastering how to create pleats will allow you to apply this technique to various designs, so let's dive in and learn this technique. First, we'll start by making the waistband part of the skirt. Select the Rectangle tool and click on the 2D view. A dialog box will appear. Set the width to 650 millimeters and the height to 45 millimeters, then press OK to create the belt pattern. Next, sew the two ends of the belt together. Select the Segment Sewing tool and sew the left end to the right end of the belt to create a loop. Now we'll adjust some settings to make the belt stiffer. Switch to the Transform Pattern tool and select the belt pattern. In the Property Editor at the bottom right, change the particle distance from 20 millimeters to 10 millimeters. Expand Bond Skive. Check the Bond option and change the mesh type to Quad Optimized. Next, place the belt on the avatar. Press Shift+F to display the arrangement points and position the belt close to the blue point on the right side. Once positioned, press Shift+F again to turn it off. Press the spacebar to run the simulation. The belt will wrap around the waist, so adjust its shape as needed. Once the shape is correct, right-click the belt and select Freeze. This freezes the belt in place, making the next steps easier. Next, we'll create the main skirt section. Select the rectangle tool again and click on the 2D view. Set the width to 1,950 millimeters, which is 3 times the belt dimension. The height can be any size you prefer. For this tutorial, we'll set it to 800 millimeters. Create the internal lines that will form the pleat creases. Since we're setting the knife pleat width to 50 millimeters this time, switch to the Edit Pattern tool. Right-click on the side edge line of the skirt pattern and select Offset as Internal Line. In the dialog box, set distance to 50 millimeters and number of offsets to 38. Then click OK. This creates 38 internal lines spaced 50 millimeters apart. Now here's a crucial part. The points created on the internal lines are also needed on the skirt's outer contour line. With all endpoints of the internal lines selected, right-click and choose To Pattern Outline from the Extend, Trim, and Add Point menu. Next, create the pleats. From the top toolbar, click the Pleats icon and select Pleats Fold. Click once on the left edge of the skirt pattern, then drag to the right edge and double-click to open the dialog box. Select knife pleats and set the number of internal lines per pleat to 3. Click OK to create the pleat lines. Next, we'll sew the pleats together. From the Pleats icon, now select Pleats Sewing. First, click on the belt section to sew it. Then, click on the top edge of the skirt to sew it to the belt, and the pleats will automatically be sewn together. We'll place the skirt on the avatar. Switch to the Transform Pattern tool, select the skirt, and press the 5 key in the 3D view to switch to the top view. Use the gizmo to rotate and move the skirt into position, ensuring it doesn't touch the avatar's hands. Once positioned, change the mesh type to Quad Optimized in the Properties editor. Internal lines are displayed on the 3D screen, making it difficult to see. Please uncheck Show Internal Lines in Garment Display. Next, switch to Thick Textured Surface from the Garment Rendering Style menu. You're now ready. Press the spacebar to run the simulation and fit the skirt onto the avatar. After the simulation, if the pleats aren't folding cleanly, you can manually pull and adjust them to correct the shape. Now, let me show you how to handle situations where the skirt doesn't fit properly. If the skirt is unruly and won't drape cleanly, try using the Strengthen feature via right-click. The key is to make sure the pleat creases aren't folded in the wrong direction. Once the pleats are shaped correctly, use segment sewing to sew the skirt's side seam together, creating a tubular shape. To unfreeze the belt, right-click on the belt and select Unfreeze. The skirt's particle distance is likely set to 20 millimeters. For cleaner and more defined pleats, change it to 5 millimeters. Select the skirt pattern and adjust particle distance in the property editor. Run the simulation to check the result. Note that smaller values increase PC load, so adjust while balancing performance. Now for the final touches. Refine the connection between the belt and skirt. Switch to the Edit Pattern tool and click the bottom edge line of the belt. In the Property Editor, check the Elastic option and set the ratio to 100. Then run the simulation again. This will create a much cleaner and more realistic fit. Hello everyone. This time, we'll create a coordinate by pairing that pleated skirt with a tank top and a hoodie. We'll also learn how to take attractive snapshots to showcase the finished outfit. To coordinate items smoothly, you need to model each item using avatars with the same dimensions and the same pose. Be careful, if the avatar dimensions differ, the sizes won't match. Now, let's start coordinating. First, open the project for the base pleated skirt. Next, add the tank top. From the top menu, select File, then Add, then Project. When you select the tank top project file, a dialog box will appear. In the dialog box, you'll see an avatar option. Make sure to uncheck it, then click the OK button. This is because the pleated skirt project already has an avatar loaded. Leaving it checked will create duplicate avatars. Next, select Maintain Current Avatar's Size and Pose, and press the OK button. The tank top is now loaded. Follow the same steps to load the hoodie project. Now all three garments are loaded into one project. Running the simulation now would cause the clothes to interfere and behave erratically. Therefore, we'll use Layer to control the order in which clothes overlap. Layer is a setting that determines the stacking order of garments. The higher the layer number, the more outward the garment is positioned. For this outfit, we'll set the layers as follows. The innermost layer is the tank top, which we'll set to layer 0. The middle layer is the pleated skirt. Since we want to tuck the tank top into it, we'll set this to layer 1. The outermost layer is the hoodie, which we'll set to layer 2. Switch to the Transform Pattern tool, select all patterns of the hoodie, and change the layer to 2 in the Property Editor at the bottom right. To tuck the tank top into the skirt, also select the pleated skirt and set its layer to 1. This setup places the tank top at layer 0 underneath the skirt at layer 1. Once you've completed these settings, press the Space key to run the simulation. You should see the garments stacking in the correct order and settling into place. After the garments have settled, stop the simulation. Next, select all patterns and reset all layer values to 0. After resetting the layers to 0, run the simulation again to check the final result. Once your outfit is complete, let's change the avatar to a more fashionable pose. Click the library icon in the top right corner and open the Avatar Female Pose folder. Double-click your preferred pose to apply it. Try various poses and choose the one that best showcases your outfit. Next, add a background to create a more professional lookbook-style image. In the library, you'll find a folder labeled Stage. This contains various 3D background objects. Double-click your preferred stage to load the background 3D object. Now it's time to take a snapshot of your finished outfit. First, turn on Quality Render for the 3D window in the top left corner of the screen. This will make the 3D view look much more realistic and polished. Uncheck Show 3D Grid in the environment display. From the menu bar, select File, then Snapshot, then 3D Window. This will open the Save dialog box. Enter a file name, select your desired file format, either PNG or JPEG, and click Save. You can select the resolution from the Preset menu or choose Custom to set your own resolution. Once configured, press the Save button to export the image. You can also export only the clothing with a transparent background. This is very useful when creating portfolios or presentation materials. Uncheck Show 3D Shadow in the environment display settings. To set the options, select PNG as the file format. Check the transparent background box, and then click Save. This will export an image with a transparent background, allowing you to easily add custom backgrounds in Photoshop or other image editing software. The snapshot feature offers two different capture modes. Single mode exports the current 3D view exactly as you see it as a single image. Multi-view mode automatically captures the outfit from multiple angles, such as front, side, and back, allowing you to see several perspectives in one go. Choose the mode that best fits your needs. Hello everyone! We're now moving into the advanced section of Marvelous Designer. Using the t-shirt we created in the basics tutorial, let's learn how to achieve a more realistic and high-quality t-shirt rendering. This time, we'll focus on rendering the collar. Since the realism can vary significantly depending on how you add thickness and apply textures, I recommend having a real t-shirt nearby to reference as you work. This will help you understand the details better. First, change the garment rendering style to Thick Textured Surface from the toolbar in the 3D view. This will display the fabric's thickness and texture more clearly, allowing you to work while checking for a realistic finish. Looking at the current collar, it's still far from looking realistic. Let's start by improving the basic settings. Since the collar is a small, detailed part, we need to decrease the particle distance value for a cleaner look. Select the collar pattern, lower the particle distance to 5 mm in the property editor at the bottom right, then run the simulation. This will improve the collar's shape. Actual collars have thickness from folding and finishing the fabric, creating a double-layered effect. Since the 3D collar uses only a single layer of fabric, it appears flimsy. We'll add thickness to the collar. Marvelous Designer offers two ways to add thickness. Method 1. Add thickness to the fabric. This method is useful when other parts using the same fabric also need thickness. In the Object Browser, click the fabric applied to the collar. Increase the thickness value in the Property Editor to add thickness. Adjust the thickness while comparing it to a real t-shirt collar. Method 2. Add thickness to individual patterns. This method is useful when thickness is needed only for specific patterns. Select the collar pattern and check the Property Editor. Increase the value of Add Thickness, Rendering under Geometry to add thickness only to the collar. Next, adjust the collar to body seam to a more realistic position. In actual garment construction, the collar seam often starts slightly behind the side neck point, so let's replicate this. First, create the point where the seam will start. Since we want a point 2 centimeters behind the side neck point, switch to the Add Point to Split Line tool. Right-click the neckline on the back bodice. A dialog box will appear. Enter 20 millimeters in line 1 and click OK to create the point at the precise location. Next, delete the existing sewing and set up a new one. Switch to the Edit Sewing tool and delete the collar to body sewing using the Delete key. Select the MN Free Sewing tool and start from the reference point created on the back neckline. Sew around the neckline and press the Enter key when you return to the starting point. Sew the collar to the seam destination and press the Enter key to complete. This creates a more realistic seam position. Next, let's add an authentic t-shirt texture. The library offers various fabric presets, so let's take advantage of them. Open the fabric folder from the library in the top right corner of the screen and look for options like cut, sew, knit, or rib. Double-click to add it to the object browser. Drag and drop the added fabric onto the body pattern to apply it. This applies an appropriate knit fabric texture to the body. Substance materials are material data with highly realistic textures. Marvelous Designer supports substance materials, so we'll apply one to the collar. Within the Fabric folder, locate the Substance folder. Add stylized ribknitwool.sbsar and drag and drop it onto the collar pattern. This applies the rib knit texture to the collar, but the scale and color need adjustment. Adjust the color and the size of the rib knit stitches. Select the fabric applied to the collar and open Transformation in the Property Editor. Ensure aspect ratio is checked, then decrease the percentage for either width or height to make the pattern smaller. Adjust to your preferred size while looking at a real t-shirt for reference. To change the collar color, open Custom Properties and modify the color via Fabric Color. This applies the realistic texture of rib knit fabric to the collar. Once these settings are complete, press the spacebar to run the simulation. If the collar appears distorted, right-click and select Strengthen. Running the simulation again will make the collar stiffer and should fix the distortion. The Strengthen function is often used when you want to correct the shape of just one specific area. Once you've shaped it with Strengthen, if you don't want that area to change further, you can right-click and select Freeze to lock it in place. The most crucial aspect of detailing is observing the real thing. Take an actual t-shirt and examine it closely. Ask yourself, how thick is the collar? Where exactly does the seam start? What does the fabric texture look like? And how large are the stitches? Developing the habit of observing these details will enable you to create more realistic representations. Hello everyone! In this lecture, we'll learn how to make the seams look more realistic. Before we begin, grab a t-shirt you have at hand. By working while observing the real garment, you'll be able to achieve a much more realistic result. First, set the 3D view to Thick Textured Surface and switch to the Edit Sewing tool. For this example, we'll adjust the shoulder seam. Select the shoulder seam in either the 3D or 2D view. The seam's detailed settings will appear in the Property Editor. In actual t-shirts, seam allowances are often pressed to one side, so let's replicate this. In the Property Editor, locate the 3D seam line option. Open its drop-down menu, where you can choose between plain seam and directional. Here, select Directional. Selecting Directional displays options for Seam A and Seam B. This setting determines which side the seam allowance is pressed toward. Select either Seam A or Seam B, and check how the seam allowance lies in the 3D view. Check the inside of a real t-shirt to choose the correct direction. Next, we'll create the appearance of the seam sinking into the fabric. If you look at an actual t-shirt, the seam area has a slight depression. In the Property Editor, under 3D Seam Line, you'll find an intensity option under Normal Map. Increasing the intensity value makes the seam appear deeper and more sunken. Decreasing it towards 0 makes the seam shallower and flatter. Refer to the real t-shirt and gradually adjust the value to find the optimal depth. Also, in the 3D seam line section, there is a thickness parameter. Increasing the thickness value makes the seam wider, while decreasing it makes the seam narrower. Avoid increasing the value too much, as it can look unnatural. Find the optimal value. For finer adjustments, tweak fold strength and fold angle to change the bending angle of the seam. First, adjust the fold angle value, and then adjust the fold strength. The default fold angle is 180. As you approach 0, the seam will stand up more, while moving toward 360 makes the seam sink deeper inward. After changing these values, you need to run a simulation to see the effect, so make sure to run the simulation and check the results. For t-shirts, you want a slightly recessed seam, so try starting with a value slightly above 180 and adjust from there until it looks right. Now that you've finished configuring the shoulder seam, apply the same settings to the other seams. The way seams appear can change significantly depending on the viewing angle and lighting conditions. It's crucial to check from various angles and confirm realism from the angle you intend to photograph. Referencing t-shirts from multiple brands helps you understand differences in brands and manufacturing methods, expanding your expressive range. These fine adjustments can make a huge difference in the quality of your final work. So take your time and keep refining until you're completely satisfied with the result. Hello, everyone. In this lecture, we'll create hems for the bottom hem and sleeve cuffs of the t-shirt. The current t-shirt has a raw cut edge on the bottom and sleeves. By adding hems, we'll make it look more like a real t-shirt. I'll show you 2 different methods for creating hems. The first method involves creating internal lines and then folding the fabric along those lines. Let's start by applying this to the body hem. First, switch to Edit Pattern and select both the front and back hemlines while holding down the Shift key. Right-click on the line and select Offset Pattern Outline. A dialog box will appear. Set distance to 20 millimeters. Check Create Internal Line. Then click OK. This extends the hemline by 20 millimeters and creates an internal line at the original hem position. Now switch to the Edit Pattern tool. Select the created internal line and uncheck Fold Rendering. We need to uncheck Fold Rendering because this internal line will become the hem's fold line. If we leave it checked, the edge will be too sharp and look unnatural. Next, create another internal line. Right-click on the internal line you just created and select Offset as Internal Line. Enter 20 millimeters for the distance and click OK. This creates the second internal line. Uncheck Fold Rendering. This completes the preparation for folding the hem. Next, we'll actually fold the hem. Select the Fold Arrangement tool from the top toolbar. In the 3D view, select the 20 millimeters internal line from the hem. A gizmo will appear. Use the circular rotation handle on the gizmo to fold both the front and back panels inward. Once you've finished folding, press the Q key to return to the Select tool. If you forget to do this, it will make the next steps more difficult. Since the created internal lines are hard to see in the 3D view, turn off Show Internal Lines. Sew the hemline to the second internal line created, then sew the edges together and run the simulation. The sewing is complete, but the hem looks messy, so we'll fix it. The cause is the particle distance being set to 20. Lowering this value improves the appearance, but it reduces the particle distance for the entire selected pattern, making the data heavier. Therefore, we'll explain how to partially subdivide to clean it up. Select the Select Mesh Box tool from the top toolbar. Enclose the hem area. It will appear green. In the 3D viewport, right-click the green area and choose Subdivide. Press the shortcut Q to return to the Select tool, then run the simulation. The hem will be neatly corrected. Adjust while balancing with the particle distance of the parts. After running the simulation, take a look at the sewn areas. You'll probably notice that the seams look deeply indented, almost like grooves. This is due to the 3D seam line and thickness settings in Edit Sewing, which we covered in the previous lecture. For hem seams, it looks more natural to have less indentation, so let's adjust these settings. Switch to the Edit Sewing tool and select the seam on the hem section. In the Property Editor, setting both intensity and thickness to 0 will make the indentation shallower or disappear. Next, we'll learn another method, using the Layer Clone feature to overlay another copy of the part. This can sometimes be more efficient, so mastering both methods is useful. First, let's handle any points that might interfere with our work. There are some points on the sleeve cuffs line that we need to delete. However, simply deleting them will change the line shape. Switch to Edit Pattern. Right-click the point. Select Convert to Curve Point. Then choose Maintain Curve. This deletes the point without distorting the line shape. Next, right-click on the sleeve cuffs line and select Offset as Internal Line. In the dialog box, enter 20 millimeters in the distance field and click OK. This creates an internal line 20 millimeters inward from the underarm line. Don't forget to uncheck Fold Rendering. This is where Method 2 becomes distinctive. Switch to the Transform Pattern tool and select the sleeve pattern. Right-click on the pattern and choose Layer Clone, Under. This creates an exact duplicate of the pattern on the layer directly underneath. Now we'll isolate just the hem portion from this duplicated pattern. Switch to the Edit Pattern tool. Right-click on the inner line of the duplicated part and select Cut. This will split the pattern into two separate pieces along that internal line. Switch to the Transform Pattern tool and delete the upper portion, the part that isn't the hem, by pressing the Delete key. Now only the hem portion remains. The cut edge of the hem doesn't have a seam yet, so we need to add one. Use the segment sewing or free sewing tool to sew the top edge of the hem pattern to the inner line of the original sleeve pattern. Once the seam is created, set both intensity and thickness to 0 in the property editor to make the seam less noticeable. Press the spacebar to run the simulation. The cuff should now have a hem added, giving you a much more realistic result. In the next lecture, we'll set up top stitch to express the indentation of the stitching. Hello, everyone! In this lecture, we'll learn how to set up top stitch, a crucial element for making t-shirts look even more realistic. Adding top stitch will significantly boost the quality of your work. Let's start by setting up the top stitch. Select Top Stitch from the object browser in the upper right corner of the screen. Set up the basic settings for top stitching in the property editor. First, select the type. Marvelous Designer offers two rendering methods. The first is the OBJ type, where each individual stitch of the top stitch is generated as a 3D object. This creates very realistic stitches, but results in much heavier file sizes. The second is the texture type, where the stitches are displayed as image textures. This keeps the file size light and ensures a smooth workflow while still producing very realistic results. For this tutorial, we'll use the texture type. Next, set the offset parameter. This determines how far the stitches are placed from the line where they are applied. First, set it to 2 millimeters. Now that the basic settings are configured, let's apply top stitching to the collar. Select the Segment Top Stitch tool from the top toolbar in the 2D view, then click on the bottom edge line of the collar. This will display the top stitch along that line. Once the top stitch is added, let's make more detailed adjustments. To edit a top stitch, you must select the specific top stitch you want to edit from the object browser each time. When selected, the detailed settings will appear in the property editor at the bottom right. You'll find an item labeled Specification. Length is the length of one stitch, and space is the length between stitches. Lower values for length and space create a denser, finer top stitch for a delicate finish. Higher values create coarser stitching with wider spacing, giving a more casual appearance. Next, adjust the thread thickness. Marvelous Designer allows you to input thread thickness in various units. Use whichever unit you're most comfortable with, and adjust the thickness while comparing the 3D window with a real t-shirt. Next, set the thread color. In the Material section, you can select your desired color from the color options. You can match the thread color to the fabric for a subtle finish, or use a contrasting color to add a design accent. Within the Material section, under Type, you can select the thread texture. For a standard t-shirt, selecting Fabric Matte is usually a good choice. However, for designs you want to emphasize, experimenting with different colors and textures can be interesting. Check the 3D box to express the degree of fabric indentation caused by the top stitch. Real top stitching pulls the fabric with the thread, which creates a slight indentation. Enable the 3D option, then adjust the intensity and thickness values, and observe the results in the 3D view. Since collar stitching is often composed of 2 top stitch lines, let's configure this. The setting to change the number of stitches exists in 2 places within the property editor. The stitch count at the top of the property editor is used when each top stitch has different colors or materials. The number of lines under configuration at the bottom of the property editor is used when all top stitch lines share the same color, material, etc. Since both top stitch lines have the same color and material this time, we'll use the number of lines under configuration. Change the number of lines to 2. Setting number of lines to 2 displays a new field called distance. This controls the spacing between the 2 stitch lines, so set it to 3 millimeters. In the 3D view, you should now see the 2 top stitch lines spaced 3 millimeters apart. This completes the realistic twin needle stitch. Next, we'll add top stitching to the hem and sleeve cuffs. Now we'll learn a technique for placing top stitching using internal lines. Hem top stitching typically consists of 2 parallel lines along the folded edge. To position the top stitches accurately, first create internal lines. Switch to the Edit Pattern tool. Right-click the hemline and select Offset as internal line. In the dialog box, set the distance to 15 millimeters and create 1 internal line. If the internal line shows up as a red line in the 3D window, it might be distracting. Uncheck Show Internal Lines from the top menu. Internal lines exist, but are not displayed on the 3D view. Since we've already configured the collar's top stitching, we can reuse those same settings. Select Copy on the top stitch in the object browser to duplicate it with all the same settings. You can rename the duplicated stitch by double-clicking on it. Give it a clear name, like Offset 0, to make it easier to manage. Select the duplicated top stitch, then in the Property Editor under Configuration, change the number of lines from 2 to 1. To position the top stitch directly on the internal line, change the offset from 2 millimeters to 0 millimeters. Select the Segment Top Stitch tool and click on the internal line lines you created at 15 millimeters and 20 millimeters. This will place 2 stitch lines precisely at the hem. Using the same steps, create internal lines under the sleeve cuffs and place top stitch lines there. Once you've applied appropriate top stitching to both cuffs and the hem, check the overall balance. Hello everyone! In this lecture, we'll learn how to create darts, an essential technique for making garments fit the body. Darts are a sewing technique where we pinch and sew fabric to transform a flat piece of fabric into a three-dimensional shape that fits the body's curves. Using the French sleeve dress from the library, we'll add darts to the bust area to create a more beautiful silhouette that follows the body's lines. From the library, double-click to load the French sleeve dress and complete the dressing process. Looking at the dress's bust area in the 3D view, you'll notice there's some looseness or extra fabric at the sides. We'll add darts here to create a beautiful silhouette that follows the bust line. There are two ways to create darts: drawing lines on the pattern in the 2D view or drawing lines directly on the 3D model. This time, we'll use the method of drawing directly in the 3D view. It's an easy-to-understand and efficient method, even for beginners. Select the 3D pen garment tool from the toolbar in the 3D view. This tool allows you to draw lines directly on the dress in the 3D view. Now let's draw the dart line. Click at the starting point on the side. Move the mouse toward the top of the bust and click. Then click at the ending point under the side and press Enter to complete. Next, make the drawn dart editable. Switch to the Edit 3D Pen Garment tool and select all the lines that make up the dart. Right-click the selected lines and choose Cut under Symmetric. Using Cut in Symmetric separates the pattern along the drawn line and automatically applies the same cut to the opposite, symmetrical position. This is a very useful feature when you want to create symmetrical darts. Once the cut is complete, the dart section will be separated into distinct parts. The small triangular pieces created by the cut are no longer needed. Select them and press the Delete key to remove them. Now we'll fine-tune the dart shape and length. Switch to the Edit Pattern tool. You can select and move the dart's apex points or the side points. Selecting a line displays its length. Aim to match the dimensions of the left and right darts as closely as possible. Here are the key things to adjust. First, the dart length. Ideally, the dart should end about 2 to 3 centimeters before the bust point. Second, the dart width. Adjust how wide the dart opens at the side seam. And third, the dart angle. Make sure the dart points naturally toward the bust point. As you work, it helps to reference photos or examples of real dresses to achieve a beautiful shape. Once you're happy with the dart shape, it's time to sew them closed. Using the Segment Sewing tool, click one side of the dart line, then click the corresponding line on the other side to create the seam. After all settings are complete, press the spacebar to run the simulation. You should see the darts sew together, creating a silhouette that follows the bust line. Hello everyone! In this lecture, we'll use the French sleeve dress to learn practical arrangement and modification techniques. We'll master various techniques that will greatly expand your design possibilities. In this lecture, we'll learn 3 key techniques. First, how to lengthen the hem. Second, how to create color-blocked or paneled designs using seam lines. And third, how to create cutout designs with holes in the fabric. Now, let's go through each technique one by one. First, we'll learn how to extend the length of the dress by lengthening the hem. There's a point on the front hem that will make our work more difficult, so let's remove it first. Switch to the Edit Pattern tool. Right-click the point and select Maintain Curve from Convert to Curve Point. This will remove the point while maintaining the curve of the line. Since we're going to lengthen the pattern, move it to create some space so the patterns don't overlap. Now we're ready to begin. Select the hemlines of all the pattern pieces, right-click, and choose Offset Pattern Outline. Set the distance to 300 millimeters. Then change the side segment type from perpendicular to extend and click OK. This will extend the hemline straight down 300 millimeters from its original position. The extended section doesn't have seams yet, so we need to extend the side seams down to the new hemline. Switch to the Edit Sewing tool and select the existing side seam. Click on the seam's endpoint and drag it straight down to the new hem. This will extend the seam. Perform the same steps for all parts, then press the space key to run the simulation. And that's it! You've successfully lengthened the dress hem. Next, we'll learn how to incorporate panels into dresses, using different fabrics and colors to create unique designs. This is an important technique frequently used in fashion design. A panel is a design technique that divides a single pattern into multiple sections, applying different fabrics or colors to each section. Now let's draw a panel line on the dress. Select the 3D Pen, Garment, tool from the toolbar. You can create lines using a combination of straight segments and curves. A normal click creates a straight line, while holding Control as you click creates a curved line. By combining these two types of clicks, you can draw any shape you want. Let's freely create transition lines in the 3D view. Click at the starting point. Then, while holding Control, click along the desired path to draw curves. When you're finished with the line, press either Escape or Enter to complete it. To end a line mid-draw, press Enter or double-click. Once you're comfortable with this technique, experiment with more creative and complex designs. Now we need to actually cut the pattern along the lines we drew. Switch to the Edit 3D Pen, Garment tool and select the line you just drew. If you drew multiple lines, hold down Shift and click each line to select all of them. Once everything is selected, right-click and select, Cut, and Sew. This will cut along the lines and automatically set up the seams for the cut sections. In the 2D view, you can see the pattern has been split into multiple parts. Next, we'll apply different colors or fabrics to these separate sections. First, let's create a new fabric. Select Fabric in the Object Browser and click Copy to duplicate it. Select the duplicated fabric and change its color in the Property Editor. Once you've chosen a color, drag and drop that fabric onto whichever pattern piece you want to change. Press the spacebar to run the simulation. Now the dress has a beautiful panel design. Don't just stick to colors. Try using different fabric textures and materials as well to create even more interesting designs. Finally, we'll learn how to create cutout designs by adding holes to the pattern. This is a great technique for creating trendy cutout styles. There are two methods for adding holes, each with different characteristics. Let's start with the simpler method first. Select the internal ellipse tool from the toolbar. In the 2D window, click and drag on the pattern to draw a circle where you want the hole to be. If you hold down Shift while dragging, you'll create a perfect circle instead of an oval. Create a circle of your desired size. If you need to adjust the position or rotation of the circle, switch to the Transform Pattern tool. Switch back to the Edit Pattern tool. Right-click the circle you created and select Convert to Hole. This will remove the circle area, creating an actual hole in the pattern. Press the spacebar to run the simulation. However, running the simulation may distort the hole's shape due to gravity and fabric movement. The following method expresses holes while maintaining their shape. For this method, start by creating a circle the same way using the internal ellipse tool. Select the circle and right-click, but this time, instead of choosing Convert to Hole, select Cut and Sew. This separates the circle into a distinct part while keeping it connected via the seam. In the Object Browser under the Fabric tab, copy the fabric. Select the duplicated fabric, and in the Property Editor, set the opacity value to 0. This creates a completely transparent fabric. Drag and drop it onto the circular cutout part. The circular area becomes transparent, making it look like a hole has been cut out. Press the space bar to run the simulation. Unlike Convert to Hole, the circular shape is perfectly preserved. These techniques we've covered today are fundamental skills, but they're just the starting point. From here, it's all about your creativity. I encourage you to experiment freely with different combinations and create your own original designs. Don't be afraid to make mistakes. Trial and error is the fastest way to improve. The possibilities are truly endless when you combine these techniques creatively. Hello, everyone. This time, we'll learn how to add ruffles to make your dress even more glamorous and elegant. We'll add decorative ruffles around the neckline of the French sleeve dress to create a beautiful, elegant look. First, we'll create a rectangular pattern that will become our ruffle. Select the Rectangle tool from the toolbar. Click in the 2D view, then in the dialog box, enter a width of 1,200 millimeters and a height of 30 millimeters in the dialog box. Then, click OK to create the rectangular pattern. Next, sew the created frill to the neckline. Select the MN Free Sewing tool. We've used this tool before when sewing across multiple pattern pieces. Start by clicking at the back center of the neckline. Then click along the entire neckline edge, going all the way around through the front center and back to where you started. Once you've completed the full circle, press the Enter key. Next, click along the frill pattern from the starting point to the ending point. Finally, press the Enter key to complete the sewing. We also need to sew the two ends of the ruffle together to close the loop. Switch to the Segment Sewing tool and click on the left end, then the right end of the ruffle to connect them. To make the ruffle drape beautifully with nice ripples, we need to adjust several settings. Switch to the Transform Pattern tool and select the frill pattern. In the Property Editor, change the particle distance from 20 to 5. we need to use a smaller particle distance so the ruffle can form delicate, natural-looking waves. Next, in the same property editor, find Add Thickness, Collision, and change the value from 2.5 to 1. This setting controls how close fabric layers can get to each other before they push apart. By lowering this value, we allow the ruffle to sit closer to the body, creating a more fitted and realistic look. In the property editor, change the mesh type from triangle to quad, optimized. Quad optimized is better suited for expressing the soft texture of fabric. In the 3D window, right-click on the ruffle pattern and select Superimpose Over. The frill will automatically position itself along the neckline. Select the neckline edge of the bodice. In the property editor, turn on Elastic and set the ratio to 100%. Setting ratio to 100% means the elastic shrinks by 100% relative to its original length, effectively maintaining its original length. This setting prevents the neckline from shrinking, allowing the frill to form a beautiful, wavy wave. Now, let's run the simulation and see the result. The ruffle should now form beautiful, flowing ripples all around the neckline. To make the frill stand up more stiffly and appear more structured, change the fabric. In the Object Browser, under the Fabric section, select your existing fabric and click Copy to duplicate it. Select the copied fabric and choose Woven Organza from the preset in the Property Editor. Woven organza is a thin, sheer fabric with good stiffness. Drag and drop this fabric onto the frill pattern to apply it. Running the simulation will make the frill stand up more sharply, creating a more elegant impression. Depending on your needs, try other fabrics. Hello, everyone. In this lecture, we'll learn how to trace patterns from images. This technique is particularly useful in several situations. First, when you want to digitize hand-sketched patterns. Second, when you have patterns created in Illustrator that you want to use in 3D. Third, when you want to photograph and recreate actual garment patterns from existing clothes. Fourth, when you need to use patterns found in books or magazines. And finally, when clients provide you with physical patterns that you need to convert into 3D models. Now let's look at the actual steps. First, prepare the image to import into Marvelous Designer. If you're working with hand-drawn or printed patterns, place the pattern on a flat, well-lit surface and photograph it from directly above, making sure the entire pattern fits in the frame. It's crucial to photograph from directly above because shooting at an angle will introduce perspective distortion, which warps the pattern. By photographing straight down, you'll capture the accurate shape and proportions, making your tracing much more precise. This is important. Before photographing, write at least one known measurement somewhere on the pattern. For example, the width across a specific section. We'll use this reference measurement to scale the image accurately in Marvelous Designer. Now we'll start working in Marvelous Designer. From the toolbar, select the Rectangle tool. Click once on the 2D view and enter 1000 millimeters for both width and height. Click OK to create a large square pattern. Now we'll create guidelines that will help us scale the image precisely. Look at the measurement you wrote on your pattern image. For example, let's say you wrote 200 millimeters on your pattern. We'll use this 200mm measurement as our reference to scale the image correctly. Select the Add Point Split Line tool. Click on the line to create a point. Place it at a suitable position. Right-click on the line. From the dialog box, enter the dimension written on the image to create a second point. Next, we'll create a guideline from these points. Switch to the Edit Pattern tool and right-click on one of the points you just created. Select Add Perpendicular Internal Line, then choose Y-axis. This will create a vertical guideline through the point. Use this guideline as a reference to adjust the image size. Now we're ready to import the pattern image. Click on Graphic 2D Pattern in the toolbar. A file selection dialog will appear. Select the pattern image you photographed and prepared. Click anywhere on the square pattern in the 2D window to place the image. The placed image will likely be the wrong size. The tool has automatically switched to Transform Graphic. Click the image to display handles at its corners. Now comes the crucial part. Resize and position the image so that the measurement you marked on the pattern, those 200 millimeters, fits exactly between the two guidelines. You can drag the corner handles to resize the image while maintaining its proportions. When the marked measurement aligns perfectly with your guidelines, the entire image will be at the correct scale. Now trace the pattern while viewing the image. From the toolbar, select the Internal Polygon Line tool. Now you'll click along the edges of the pattern in the image to trace its outline. Click normally to create straight line segments between points. If you need to trace a curve, hold down the Control key while clicking. This will create curved lines that follow the contour of the pattern. If you need to switch from drawing curves back to straight lines, double-click to end the current line segment, then click where you want to start the next straight segment. When you've completed the entire outline, double-click on your starting point to close the shape. Make sure you trace the entire outer perimeter of the pattern, creating a completely closed shape. This is crucial. All lines must connect properly with no gaps or overlaps. If the shape isn't closed, or if lines intersect incorrectly, Marvelous Designer won't be able to recognize it as a valid pattern. Now switch to the Trace tool and select all the lines you just drew. You can drag a selection box around them or hold Shift and click each line. Then right-click on the selected lines and choose Trace as a pattern. The area enclosed by your lines will be converted into an actual pattern piece. You can see the pattern generated in the 2D view. Since all patterns are only half, we'll unfold and duplicate them. Switch to Edit Pattern. Right-click the center line, and select Unfold Symmetric Editing with Sewing to unfold the pattern to the opposite side. Set this for the front, back, and collar. Since only the left sleeve exists, switch to Transform Pattern, right-click, and select Symmetric Pattern with Sewing to create the right sleeve by flipping it. Place the traced patterns on the avatar and sew them together. Once you've positioned all the pattern pieces and sewn them together, press the spacebar to run the simulation. Watch as your traced pattern transforms from a flat image into a fully three-dimensional garment draped on the avatar. It's amazing to see your hand-drawn or photographed pattern come to life in 3D. Hello everyone. In this lecture, we'll learn about the final step in Marvelous Designer editing UVs and exporting your garment. This is an essential step for bringing the garments you've created into other 3D software like Blender. First, let's understand what UVs are. UVs are essentially a flattened, unwrapped version of your 3D model's surface. They allow you to apply 2D texture images onto the 3D geometry. Think of it like this. A 3D garment is a three-dimensional box, and UV is the flat, unfolded diagram of that box. This flattened layout allows you to accurately apply 2D image textures to your 3D model. If the UV placement is incorrect, the texture will appear distorted, causing patterns to blur or become squashed. In other words, UV editing is an essential process for achieving a high-quality finish. Now, let's actually start UV editing. Displaying the UV editor. From the menu bar, click Window, then UV Editor to open the UV Editor window. Once the UV Editor opens, you'll see tabs at the bottom of the screen. These tabs allow you to switch between the 2D pattern window and the UV Editor. When you open the UV Editor, you'll see your current UV layout. The UV Editor shows a grid of tiles. Fundamentally, all UVs must fit within the 0 to 1 tile. This 0 to 1 tile corresponds to the range of the texture image. A common issue is that as you work on your garment, the UV layout can become disorganized. Pattern pieces may extend outside the 0 to 1 tile or overlap with each other, which we'll need to fix. First, we'll reset the UV layout to a clean state. Right-click anywhere in the UV editor and select Reset UV to 2D Arrangement. This will rearrange all the UV islands to match the layout of your 2D patterns. Next, right-click again and select Fit UV to 0 to 1. This automatically positions all patterns to fit within the 0 to 1 tile. Before we export, let me share some crucial tips for optimal UV layout. If you place your pattern pieces too small within the UV space, you're essentially wasting texture resolution. This will cause your fabric patterns and details to appear blurry or pixelated, losing realism. Carefully move and rotate your pattern pieces to minimize empty space. The more efficiently you pack the UVs, the better texture resolution you'll achieve across your entire garment. Once your UV layout is optimized, it's time to export. Marvelous Designer supports several export formats, with OBJ and FBX being the most common. For this tutorial, we'll use FBX format because it offers excellent compatibility with Blender and supports animation data if you need that functionality in the future. Go to File, then Export, and select FBX. A Save dialog will appear. Choose a location, give your file a name, and click Save. This will bring up the FBX Export Settings dialog. Let's go through each important setting. Let me walk you through the key export settings. First, for the avatar option, select Exclude Rig, since we don't have animation data. Second, for object split, choose Single Object. This combines all your pattern pieces into one unified mesh. If you selected multiple objects, each pattern piece would export as a separate object. Third, for fabric thickness, select Thick. This ensures the fabric thickness you set in Marvelous Designer is preserved in the export. The Thin option would ignore that thickness. Fourth, and this is important, check Unified UV Coordinates. This applies the UV layout we just carefully organized. Fifth, for image size, I recommend starting with 2048 pixels. This gives good quality without huge file sizes. You can go up to 4096 for higher quality, or down to 1024 or 512 if you need smaller files. For the texture maps themselves, enable Diffuse Map and Normal Map. These are the most essential. Sixth, for file type, select Binary. This creates smaller files that load faster. Seventh, set the FBX SDK version to 2020 for best compatibility. Eighth, for scale, choose meters. This is crucial because Blender uses meters by default. If you use the wrong unit, your garment will appear gigantic or tiny when imported. Finally, for texture, select Embed Media. This packages all texture images directly into the FBX file, keeping everything in one convenient package. Once you've configured all these settings, click OK to start the export.